In this question, we are given 4 figures. So to find the next figure, we are going to note that there is an increasing pattern here. So in the 4th figure, we notice there are 1, 2, 3 lines that divide this triangle internally. So now in the 5th figure, we will have a triangle. By right, you should be using a ruler to draw the triangle. Then for our figure 5, since in figure 4, there are 3 internal lines, so in figure 5, we should have 4. Therefore, we are going to try our best to divide this equally by the 4 lines. It should, as far as possible, be of equal interval. So, in your case, you should be using a ruler. Okay? And this is done. Now for the next part, you notice here there are some numbers here to describe the patterns up here. So let's try to find some patterns among the figures here. You notice something? And there's of course a relationship between the two terms here. So it means that if it is a 5th term, we should get 5 times 6 divided by 2. That will give us 15. And for the general term, using this pattern, we have n bracket n plus 1 out of 2. Or you can further simplify it as n squared plus n out of 2. However, we should be writing this first so that to show how this general form is related to the previous terms. Now, part 3 asks for the 77th figure. So using our general form that's obtained previously, we can substitute 77 into this. And eventually we will get 3003. And for the next part, it says find the value of n if the figure has 66 triangles. So if it has 66 triangles, you are trying to say that this general form, if we put the number here, we will get 66. Therefore, to simplify this, we try to solve this equation. Of course, some of you actually use square root and then find the nearest term. It is still feasible, but I just want to show you that we could use another method to find the figure. And this will actually require us to bring in some reasoning. Now, this is pretty straightforward, like what we have been doing for solving equation. Now, you notice that I have actually removed 132 on the right hand side. And so, you notice this becomes a quadratic equation. On the left, it is the quadratic expression, but because it is written as equal to 0, therefore we have a quadratic equation. And if we are going to factorize the left-hand side, we will get this. This is what you will see in set 2. And now, for n minus 1 times n plus 12 equal to 0, it means either one of them must be 0. So let's check. If n minus 11 is equal to 0, then n will be equal to 11. And if n plus 12 is equal to 0, then n would be negative 12. And since we know that n is the position of a term, it cannot be n equal to negative 2 because n must be a positive integer. So in this case, we conclude that it is actually the 11th term.